Hi, very good morning to you. It's Dean from maverickstar Observatory. A little bit later on, we're going to go over to our website, poleshiftnews.com, and just have a look at some of the recent updates I've made over the last few days. Before we get into the video, just like to say a big thank you to those few over the last few days that have been, supporting us with a bit of donations, and also I'd like to thank our superstars that recently sent some data, Scott from Arizona and Kendall. And I'll try this week to get hold of Jeff in Australia and see if he's got some data for us, along with some muon results. But we're looking at the James Webb infrared image, and this is the result of a 12-hour or a 12.5-hour exposure of a viewpoint the same size as a grain of sand. So you can imagine this times trillions. If we just look everywhere in our universe, we're just going to see more of what we're seeing here. You can pick out spiral galaxies, nebulae, all sorts of stuff. It's quite an amazing photo. One thing I was pondering is that if we were looking at infrared images, I'm just wondering how they managed to incorporate the colours that we see in this image. And one of the things I was thinking about is if they are artist impressions or they are actually the true colours of what we see. It's like looking into a jewel box, isn't it, of gems, rubies, emeralds, things like that. I said to my partner this morning, I'd love to split this image down into probably 5 sections, 5 at the top and 5 at the bottom, and have this image in the living room. She says absolutely no. But for me, I could just stare at this for hours and on end. It really makes us feel unimportant is the word that comes to mind. When you think that we live in just one of these spiral galaxies that we see millions of, in just this little image of the size of a grain of sand. We see these stars that were burning as bright as what we are seeing them today, only because that light has travelled for probably 13 billion years. It just makes us feel so insignificant. And then when you bring it back to our galaxy and back to our solar system, back to our Earth, you think to yourself, why in the hell can't we just live together without killing each other, like what's going on in the Ukraine? You just wonder why. This was the result of a lot of people's work, from NASA, the European Space Agency, the Canadian Space Agency, and a lot of other departments in America. It cost to get this image to us so that we can see it, over £10 billion in funding for the project. And this is a joint effort. It shows us that we can achieve these amazing things if we work together. Hopefully one day human beings on this planet will live in peace with each other. There will be no fighting anymore, hopefully, about boundaries, borders, race, culture, ethnicity. None of that will be, hopefully, at one point in our future relevant. It's an amazing photo. I've been enlarging this and just having a look around at all the different things that you can see in this image, all the different galaxies. It's just truly amazing. I hope more people appreciate what it is that we're looking at here and what it took in order to get that. And that is exactly why I'd love this in my living room on the wall as a picture. You could spend many hours just looking at it in awe, because we're so insignificant. We're just not even a grain of sand in this image. We're nothing. Our Earth is nothing. It makes you wonder as well how we all came from one thing. The standard theory is the Big Bang 13.8 billion years ago. Did it all begin from a single source? I suppose in time to come, the James Webb telescope might help answer that question or confirm that, that it is the case. Everything has come from the single source of a big bang. Just truly amazing, isn't it? I'd love to know what your thoughts are on this image, what you actually think, how it makes you feel, whether even you'd like it on your wall in your living room, and whether you could convince your partner to allow you to do that. I suppose you have to be really into your science to appreciate things like that. Okay, let's go over the website and have a look at the data that our superstars have collected for us. And of course, in a couple of days' time, 4 days' time, we're going to do a pinpoint of the magnetic North Pole, because we can look at images like this, but we have to bring it back down to ground on Earth. And of course, the realization that something unique is taking place with our planet right now, and it's a rare event. An unusual anomaly, and of course I'm talking about the magnetic pole reversal that is currently underway. And I have been talking about the fact that we could be only 8 months away from some significant uptick in the migration of the magnetic North Poles. This is a theory, and I will admit is my own theory. I've laid it down on the table as a very possible thing that could take place as we observe the magnetic North Pole migrating over the northern hemisphere over the next 8 months. We could see some further increases in distance over speed. We've been spending a lot of time now collecting data on the magnetic North Pole migrating over the northern hemisphere. I think now for about 5 years we've been doing the TriMag data, but Kendall was telling me now it's coming up on the 4th year anniversary that he's been supplying his data to us. And that is a remarkable effort, guys. This is just another demonstration of when people work together from different countries. The United States, as we have got Scott down there in Arizona, Tucson, Kendall in Canada, Jeff in Australia, and hopefully there will be many more join us in the years to come, that we further delve into this rare anomaly that's taking place and study it more. When hopefully one day we will have equipment in Russia, Brazil, South Africa and other parts of the world, and we may even make discoveries of our own. It can only be done with the help of you guys out there and people like Scott, Kendall and Jeff, and a few of the others that have helped us, like some of our other superstars around the world that have collected data at various points for us. Okay, let's go over to the website and check it out. So first of all, we're going to take a look at some of the data from Tucson, Arizona. Scott has sent us the month of June data last month, from the 1st to the 30th of June 2022. It's been a little while since we had some last from Scott, but I'm very grateful, as much as I suppose you guys are, for whatever data we do get. And what we can see instantly by looking at this data is there is still not a lot of progression with the magnetic intensity in that region of our world. And that's pretty much the same case for other regions, like the data that we get from here in the UK or down in Australia or over Canada. At those locations where we've got magnetometers at the moment, there is nothing significantly taking place, and we should be grateful and thankful that that is the case, because when we do start to see major changes in the intensity over those regions, we know something is definitely going on in the ground. Good thing about this is that we've got that equipment out there, and the nice thing about having machines like what we've got, the magnetometers, collect the data, is that it eliminates the human error. We do see sometimes, time to time, spikes in the data where it jumps up dramatically, but we can completely outroll that, because we know that the behaviour of the intensity never jumps up like that, or at least to this date we've not seen it do that, and we would presume that it wouldn't do it in one location as well. If we're seeing dramatic changes, we're going to see them in our Canada region, in the Arizona region, and in the Australian region, and here in the UK we're going to see it all together. So the good thing is that we're just sitting here now waiting for things to start to take place. When we look at the magnetic dipoles of our planet and we go on the data that we collect from the TriMag system, that's a little bit different. What we have noticed over the last 9 months is a slight uptick of about 20% in speed. So it's covering a little bit more distance over that space of time than it used to do. And that's really interesting because, when we go back to that theoretical point I made, where we could see a dramatic change in the increase of speed over the northern hemisphere of the migrating poles, it could be because it's crossing that boundary of weak and strong field lines. The experiment shows us that that's the case. I know a lot of people have struggled to get the concept because they're saying you're using two magnets, but it's not the case of using two magnets. The magnet that I'm using, that's rotating on that motor, is representing what's taking place in the interior of our core, and we're just using the compass to show us how that responds. So let's just put it this way: if the magnets onto the top of that motor are what's representing what's happening in our core of our Earth, then the compass is just the measuring device of that. And there is no difference. There's no two magnets involved, so to speak. We're just really trying to get an idea of what happens with our viewing device, which is the compass, when something rotates in our core. And we know it's rotated, like the experiment shows us, almost 40 degrees to this point. The only way to know for sure if it is feasible now is just in time. We've got 9 months before we get to that point. 8 months now. Time is rapidly approaching that point where we're getting close to that 40 degrees. Whether it will speed up or not at that point remains to be seen. But what I will say this is that from the study of the previous magnetic reversals, it does cross a threshold and accelerates. That's why I introduced that experiment to you guys, because like I said, you have to have all these ideas on the table, and if one of them is right, all well and good. If not, then you move on to the next possibility. What we do know though is that if things start to increase in 8 months' time, the magnetosphere of our Earth is going to weaken considerably, and that is not going to be a good thing for us. We're not even ready for it. We're not prepared for it. Anyhow, let's take a look at the data that we got from Kemble, and then we'll have a look at the Earth Alpha at a glance and probably talk a little bit more about these things. So just looking at Kemble's data that he sent us from Canada, what we can see and what we're looking for is slight changes in the frequency, and we see that towards the end of his data. At the end of that week, you can see that the frequency is actually thinning out a little bit, so the troughs and peaks are getting smaller and smaller. So there's something there we can look at. Is it to do with solar activity? Because at the moment we have an unsettled geomagnetic field due to some solar weather at the moment arriving at our surface of our atmosphere on Earth. So is it interacting with the magnetosphere? And in particular, is it interacting with the region over Canada that we are monitoring at the moment? These things are really for us all to have a look at. We just collect the data in that region. If you want to, we've got a page on our website dedicated to solar activity, and you can do your own research by using some of the materials that we provide on this website from the data that we collect. This is, after all of our observatory. The maverickstar observatory is a public effort. We've all chipped in a little bit towards this, and the description and the comment section down there is for you to share ideas on what you see based on the data that we collect. But big thanks to people like Scott, Campbell, Jeff that send us this data. It's not easy for someone to take up a bit of space in their own home, and for like Campbell has and Scott has and Jeff has for years now send the data back to us. It's a big effort, and I'm sure that we're all very grateful for that, because with this observatory we collect our own data. That's a big thing. We're not relying on NASA, the European Space Agency, and we're not regurgitating what they're telling us. We're actually recording what we see and relaying it back to our little subscriber base here on YouTube, and those that regularly visit us on the website. It's got to now nearly 20,000 views every month, which is amazing. Sorry, not every month, every week we have 20,000 people view what we put up on that website. So if you've not been over to poleshiftnews.com, feel free. I'm sure there's plenty there for anyone that has any interest in the anomalies that we cover on there. And it might be Schumann residents. We've got some great live feeds feeding into the website on a daily basis on the Schumann frequency. We cover the Arctic ice progression. Now, if you go over there, you'll see that for the last 10 years at least, the Arctic ice is rebounding. Why aren't they mentioning this on the mainstream media? As well as I know, it's because it doesn't fall in line with their carbon taxes, their carbon credits, and for that reason they're not going to mention it, are they? Because we're all supposed to be in the knowledge of the ice is retreating, sea levels are rising. They don't give any credit for a subduction zone, and islands that are on subduction zones. Obviously, if it's going under another plate and that island's on that subduction zone, it's going to seem like the sea levels are rising. But they don't say, well, it could be also due to the fact that it's on a plate which is subduction in a subduction zone, so it's going under another plate, and therefore it is going to go under the sea at some point. The thing is with human beings is that we have to realise that it is in our nature to migrate. And we know this because when we look at the Mayans, when they abandoned all those pyramids in South America, it was because the climate or the region could no longer sustain them living there. Probably because at that point in time, water was becoming, scarce, and therefore it could no longer sustain a population. We have to come to grips with this. We have to be a migrating species, and that's why I say, when we do go further back into this glacial period, we're going to be left with no choice but to abandon literally continents in the north and south hemispheres of our earth and find land that can sustain us. And I've talked about this a lot. When you're talking about 8 billion people cramming into some small regions of the earth where it is possible to cultivate an amount of food, well, what is going to happen at that point is nothing short than natural selection at that point. It's unfortunate, but that is the nature in this world that we live, and this is certainly something that's not been talked about enough. So the other page that I updated yesterday on the website was Earth Health at a Glance. This just covers, as a lot of you know, a lot of the anomalies that are taking place, and obviously we take measurements of atmospheric CO2. As you can see there, it's at 446 parts per million. We've got our own oxygen sensors. We can calculate how much oxygen is in the atmosphere by using that state-of-the-art technology, a Luminox sensor that is in there that we built ourselves. We've also got there from last month's the longitude and latitude of the positioning of the magnetic North Pole. We've got the radiation background, which is slightly up from last month. Usually it's around about 00.12. It's gone up a little bit. Maybe that is to do with the geomag at the moment being unsettled. We've got the largest earthquake within the last 24 hours from yesterday, as you can see there. We've got the muons per square metre per hour in the UK at 530. In Canada they're at 864. Sunspot numbers are on the increase. There's 7 active regions at the moment. As you can see, the geomagnetic field as a result of that is unsettled, and solar X-rays are normal. And of course our jet streams are unstable and have been for a long point in time, and you know, the current magnetosphere strength is, as you can see, 50 microteslas, and that is the Earth Alpha at a glance. The only thing I forgot to mention there is that we've got 25 active volcanoes in eruption at the moment. So that's a quick rundown on what's going on with our Earth. The only other thing to say, guys, is, you know, it is amazing when we see human beings and organisations all pull together for a common goal. And, you know, that's why, you know, I'll just take a few minutes here to mention the importance of what we do here at our observatory. And it is our observatory, and it wouldn't have been possible if it weren't for like-minded people that share an interest of what's taking place in their world as it changes. And, you know, we're just trying to do our little bit here for you guys, and, you know, keeping you reassured of those changes, and, you know, trying to keep you up to date on as and when they change. Guys, I'll just briefly mention there's a link down there if you want to help support us. It'd be great to see a bit of support. We are running obviously a little bit low because we've only made a couple of videos this month, and it is sadly the case that when we make a video, you know, a couple of people chip in. It'd be nice to see a few more people, you know, support what we do here. You know, I dare say one day people will appreciate it a lot more. And, you know, we're going to be one of the day in the future, one of the only observatories that has, you know, covered these events at the resolution that we have. You know, that is, at every 3 seconds we take another sample of the magnetic North Pole and record its position at the end of the month, which is a couple of days away for us at the observatory. As you know, on the 17th we do a magnetic North Pole pinpoint location for you and show you where that is on the map and how close we are away from that theoretical 40-degree mark, which is now only 8 months away. So guys, links are down there if you want to help support us. We certainly hope you do. And the only other thing for me to say at this point is, you know, you take care of your loved ones as always. Bye for now.